Lesson 2: Water Pollution and Aquatic Ecosystems. Water has unique properties. For instance, its solid form, ice, is less dense than liquid water, which allows ice to float. In the environment, water enters the ground surface through infiltration and moves downward through soil and rock via percolation. When organic waste enters water systems, it creates a biological oxygen demand, or BOD. This is the oxygen required by decomposers to break down biodegradable organic waste. Heavy pollution causes an oxygen sag curve just downstream of a discharge point, where dissolved oxygen falls dramatically while BOD rises as decomposition happens. Eutrophication causes similar issues when algal blooms die off. Dead algae are decomposed aerobically, raising BOD and consuming dissolved oxygen, which stresses aquatic life. In heavily polluted anaerobic septic zones, decomposers produce gases like hydrogen sulfide and methane instead of fully oxidizing organic matter. Thermal pollution from heated water discharges also lowers dissolved oxygen and artificially raises the metabolic rates of aquatic organisms, causing stress. To mitigate pollution before it reaches nature, sewage undergoes strict treatment. A typical Maltese sequence starts with preliminary screening, followed by primary sedimentation, secondary aeration, and finally tertiary treatment and disinfection. This process reclaims clean water. First-class water is potable quality for drinking, whereas second-class water is lower-grade reclaimed water for non-potable reuse. If industrial acid drainage occurs, acidification increases toxic metal solubility, but it can be mitigated by adding lime or limestone to neutralize excess acidity.